Well, welcome back, ladies and gentlemen. We want to look at properties of exponents. So we introduced the definition of an exponent, and we were able to exponentiate certain numbers. Now we want to actually look at some properties of exponents. These are very important. Let's say you got m and n. M and n are positive integers. Again, positive integers are counting numbers that are positive, like 1, 2, 3, 4, and so on. So here's our first property. Let's see. If I have a to the m power times a to the n power, this turns out to be a to the m plus n power. Now let's see if we can give an example of that first one. I'll show how that actually works. That's the first rule we want to learn for exponents, but why does that work out? Let's see. Let's say I got, a to the third times a squared, right? What does a to the third mean? A to the third means what? Triple A, means you're multiplying a together 3 times. What does a squared mean? A squared means double A, right? It means you're multiplying a together 2 times. So what have I done? I've listed 3 copies of a for a to the third, 2 copies of a for a squared. How many copies of a do I have here in total? I have 5, right? 1, 2, 3, 4, 5. So I got a to the 5th. So essentially what we've done, we've taken 3 copies of a and then 2 copies of a. So altogether we have a total of 5. So it's 3 plus 2, 5, right? So that's kind of the reasoning behind the rule. That's why you add the exponents together like that. All right, here's another one. Rule number 2. Let's say I got a to the m divided by a to the n. So what do I do with the exponents here, you might ask? Well, you take a common base. A is called the base. I take m minus n. I take the top exponent minus the bottom exponent for the new power of a. Let me show you how that works exactly. Let's say that I were to have a to the 7th on top. And on bottom I were to have, a squared. Now think about what a to the 7th means on top. What does a to the 7th mean on top? It means what? A. Do I got 7? 1, 2, 3, 4, 5, 6, 7. Yeah, that's 7 on top. Now a squared, what does that mean? I got 2 a's on bottom, right? 2 a's on bottom. Now, there's a property of fractions, so you got to know a little bit about fractions here. You cancel the 2 a's on top with the 2 a's on bottom, and what are you left with? You're left with a, 5 a's. In other words, hey, a to the 5th power. So essentially what we did, we took what? 7 minus 2, right? We canceled 2 out on top with 2 out on bottom. We're left with a total of 5, a to the 5th. Yeah, so that's kind of the rationale behind that rule. 7, take away the 2 on bottom. Get a total of 5. All right, let's do a number 3 property. How about a to the 0 power? A to the 0 power. A to the 0 power is 1. So I remember when I was in high school that I was taught a to the 0 power is 1. Anything to the 0 power is 1. Well, I memorized that. I didn't really understand it until I got to college. So why is a to the 0 1? Let's see. Let's see if we can understand number 3. Developing this idea. A to the 0 power. Well, remember, 0 right here, that's the same thing as 1 minus 1. So I'm going to write this as a to the, 1 minus 1, right? 1 minus 1 is the same thing as 0. Now, if I use the previous property in reverse, property number 2 in reverse, that'd be the same thing as what? A to the 1 over a to the 1. But wait a second, what happens when you take anything over itself? You just get 1, right? a to the 1 over a to the 1 is 1. There you have it. A to the 0 is 1. Okay, that's the rationale behind that. Let's see, can we do a number 4 here? How about, okay, this one's a famous one. A to the m, parentheses around that, to the n. Now, this is an important one that you don't want to mix up with number 1. So number 4, do not mix it up with number 1. This is going to be a to the new exponent is going to be m times n. M times n. So let me illustrate this exactly how it works. Scroll down a little bit. Scroll down a little bit. Scroll down a little bit. Number 4, illustrating this. Let's look at an example. Let's do a to the 3rd to the 2nd. A to the 3rd squared. First of all, let's focus on what does a to the 3rd mean here in the parentheses. A to the 3rd means triple A, right? A times A times A. Now on the outside of that parentheses, we got a square. So what does that square mean? That square means we have 2 copies of those triple A's, right? So we're going to have what? Triple A and triple A, right? 2 copies. Triple A, triple A. So if you count up how many A's in total we got 6, right? 1, 2, 3, 4, 5, 6. Yeah. So essentially what we did, we multiplied here this 3 and this 2 to get 6, right? That's exactly what we did. We multiplied 2 times 3. Right? We had 2 copies of 3. 2 copies of 3, or 2 groups of 3. So when I was back in, what grade? I guess it was 1st grade when I was learning multiplication. So when they taught me what was 3 times 2. Now let me say it this way, 2 times 3. 2 times 3. This is the way they would have done it in 2nd grade. We learned 1st grade or 2nd grade. You learn that 6. So basically the way they teach it is you have a group of 3. Let's say you got a group of 3 dots and another group of 3 dots, right? 2 groups of 3. Well, that's exactly what this is right here, right? It's 2 groups of 3. So 2 times 3. 6. Okay, so that's the inspiration for property number 4. Property number 4. All right, so I guess, let's see. Oh, no. Don't want to lose that. All right. Let's do a number 5. Number 5. How about a, b to the nth power? So that's a times b to the nth power. Well, what you can basically do is distribute the exponent over top of those 2 components. You can do a to the m times b to the m. Yeah, so exponents distribute over top of multiplication. Exponents distribute over multiplication. Okay, I'm going to clean some of this up down here. I'm going to show you how this works. You can see how that works. Why am I allowed to distribute exponents over top of multiplication of 2 components? So number 5. Let me do a little example here. Number 5. Let's say I got a, b to the 3rd power, right? ab to the 3rd power. What does this mean? This means I have ab, 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 right? It means I have triple ABs. AB, so it's 3 copies of AB. Now, there's some properties in the real number system like associative properties and commutative properties. It allows me to rearrange terms and put parentheses around terms. What I can do, I can put all the A's together. I can put all the B's together, the 3 B's together. And a fancy name for triple A is what? A to the 3rd. And a fancy name for triple B is what? B to the 3rd. So yeah, notice our final outcome here is a to the third, b to the third. So essentially what we've done, we've taken this exponent of 3 and we distribute it, right, over the a and over the b. So that's basically what property 5 is getting at. I've shown it here, example 5, how that precisely works out. Number 6. Ooh, I got to write it down up top, the general property. Let's say I got a fraction, a over b to the nth power. So if I have a fraction, a over b to the nth power, I can distribute the nth power to the top, the numerator, and distribute it to the bottom, the denominator. So essentially what we're saying here is exponents distribute over fractions to their numerators and denominators. So let me show you that one. So let's say we got a over b, a fraction, to the third power. So what does that mean exactly? That means what? You got a over b times a over b times a over b, right? 3 copies. That's what that exponent means. It means you have 3 copies of a over b. Now, how do you multiply fractions? The tops go together, the bottoms go together. So on top you're going to have a times a times a. And on bottom you're going to have b times b times b. In other words, triple a to the third. In other words, on the bottom, triple b to the third. Yeah, so notice that this exponent here, 3, distributed to the top and the bottom. So that's what 6 is all about. Now what do you want to do? 7? 7 gets into negative exponents. Now we haven't talked about what it means to have a negative exponent. So let's say you got a to the negative m power. So let's say you got a negative exponent. This is the same thing as 1 over a to the m power. Let me show you how that one works. See if I can scroll a little bit. All right, good. I could scroll. Fantastic. Let me clean this up from earlier. So I'm trying to show you how number 7 works using the definition of exponentiation. Number 7. So let's say I got a to the negative 3, okay? So I want to focus on this negative 3 exponent right here. How can I write negative 3? Well, negative 3 is the same thing as you can think of as that, what, 0 minus 3. Right, 0 minus 3 is the same thing as negative 3. Now, if you go back a little bit, and you use number 2, property number 2, remember that's the one where you're subtracting the exponents, you can write that in reverse as a to the 0 on top divided by a to the third on bottom. And then on top, you can use a to the 0. Remember, a to the 0, property number 3. So let's use property number 3. A to the 0 power on top is going to be 1. And on bottom, we got what? A to the third. Yeah. So that's exactly the outcome that we should have expected from property number 7. So when you have a negative exponent, over a positive number, you put on a 1 in the numerator, and in the denominator, you make a to that exponent positivized. Yeah, so basically take the exponent to the bottom, take the exponential expression to the bottom, and make it a positive exponent. Yeah. Okay, one final property. Number 8. Number 8 is directly related to number 7. It's a little more complicated, so I'm not going to really get into the details of it. I don't think... I might get into the details if you want to see the details. Let's say you got a over b to the negative m power. So let's say you got a fraction this time to a negative power. Well, what you can do, you can flip the fraction, and make the exponent positive. Yeah, flip the fraction makes the exponent positive. I guess I'll show you how that exactly works. That's not what I wanted. I can show you how that works. Okay. Do you want to see number 8's a little complicated showing you how it works. I'll work through it though. It requires some tricks with fractions. All right, so let's say I have a over b to the negative third power, okay? Negative third power. So we want to focus on that negative third power. So remember what it means when you have a negative power. Let's go to property number 7. Property number 7, which we just covered, says when you have a negative power, you're going to put a 1 on top, and on the bottom, you're going to take your base, which in this case is not a, but it's a over b, right? A over b. And you're going to raise that to the positive version of your power. So rather than a negative 3 down bottom, you're going to have a positive 3 down bottom. All right? So I'm going to have 1 on top. And now what I'm going to do, I'm going to use property crab. Nope. Not working. I use property number 6 to distribute my exponent. So you look at property number 6. Property number 6 says you can distribute your exponent over top of a fraction. So I'm going to have here a to the third divided by b to the third right here. Now that looks very awkward, right? We have 1 divided by a to the third divided by b to the third. Now, I don't know if you've ever learned this, but when you divide by a fraction, when you have a number divided by a fraction, what you can do is keep the number on top, which is 1, change that blue division bar to multiplication, and then flip your red fraction. It becomes b cubed over a cubed. That's called stay, change, flip. Stay, change, flip. You stayed the top stayed the same. You changed division to multiplication, and then you flipped the bottom fraction. The bottom fraction, a to the third, b to the third, changes to b to the third over a to the third. All right, so let's keep going. Let's see if I can get this to work. Okay, there it goes. Pen is working. So this is the same thing as what? B to the third over a to the third. And then what we can do, we can go back and look at property number 6 in reverse. Use property number 6 in reverse, and we can write this as, not great. There it goes. B over a to the third power. So that's exactly what our property number 8 was all about. Pay attention to property number 8. It said that when we had a negative exponent over a fraction, so a over b to the negative third power, what you would do, you would flip your fraction, turn it into b over a, and make the exponent positive. Yeah, so there are all the properties of exponents. Make sure you learn all these properties of exponents. Numbers 1, 2, 3, 4, 5, 6, 7, 8. 8 properties of exponents you need to become familiar with. So in our next video, what we're going to do, we're actually going to put these to use. We're going to use these properties of exponents to simplify exponential expressions.